Rational exponents, nth roots. So let n be a natural number. If a and b are real numbers and a to the n is equal to b, then we say that a is an nth root of b. So it says here that n is a natural number. What is a natural number? A natural number are positive integers such as 0, 1, 2, 3, and so on. And real numbers. What are real numbers? Real numbers are all numbers that can be found in a number line, including both rational. Rational numbers are those that can be expressed as fractions, and irrational. So when a to the n is equal to b, then we can also say that a is equal to the nth root of b. For example, both 3 and negative 3 are square roots of 9 because 3 squared, that's 3 times 3 is equal to 9, and negative 3 squared, that's negative 3 times negative 3 is also equal to 9. Also, both 2 and negative 2 are fourth roots of 16 because 2 to the fourth, that's 2 times 2 times 2 times 2 is equal to 16. Also, negative 2 times negative 2 times negative 2 times negative 2 is equal to 16. That's negative times negative becomes positive times negative becomes negative times negative becomes positive. So that's also equal to 16. And 2 is a cube root of 8 because 2 times 2 times 2 is equal to 8. And for this example, negative 3 is the fifth root of negative 243. So that's negative 3 times negative 3 equals positive 9 times negative 3 is equal to negative 27 times negative 3 is equal to positive 81 times negative 3 is equal to negative 243. So the fifth root of negative 243 is equal to negative 3. As the example suggests, square roots, fourth roots, and all even roots of the positive numbers occur in pairs, one positive and one negative. In these cases, we use the notation the nth root of b to denote the positive or the principal nth root of b. So we are going to use the positive for the principal nth root. So say for example, the fourth root of 81 is equal to 3. That is, the principal fourth root of 81 equals 3. And that means that the principal fourth root of 81 is not equal to negative 3 because we are going to use the positive for the principal nth root. But we can also say that the negative of the principal fourth root of 81 is equal to negative 3. This symbol is called the radical sign. And the number within the radical sign, let's say for example 25, that is the radicand. And the number that we are going to use, let's say for example for square root, that's 2, but we're not going to actually put 2 here, but this number is the index. This number here is the radicand, and this symbol is the radical sign. So since this is square root, then we don't need to write 2. So we'll just write the square root of 25 is equal to 5. Let's remember the laws of exponents. So for product rule, a to the m multiplied by a to the n is equal to a raised to m plus n. For quotient rule, that's a to the m divided by a to the n is equal to a to the m minus n. For power of a power rule, that's a to the m raised to n is equal to a to the m n. For power of a product rule, that's ab raised to m is also equal to a to the m multiplied by b to the m. For zero exponent rule, a to the 0 is equal to 1. For negative exponent rule, a to the negative m is equal to 1 over a to the m. And for fractional exponent rule, a to the m over n is equal to the nth root of a to the m. In this example, 2 raised to the square root of 5 raised to the square root of 5. We are using the power of power rule. So that's 2 raised to the square root of 5. That's also 5 to the 1/2. And then you multiply it by another 5 to the 1/2. But now you are looking into these two numbers that could be seen as like this. So that's also equal to product rule. So that is equal to 2 to the 5 raised to 1/2 plus 1/2. And that's equal to 2 to the 5. 1/2 plus 1/2 equals 1. And that's equal to 5. So that's 2 to the 5. Or that's equal to 2 times 2 times 2 times 2 times 2. The answer is 32. In summary, the principal nth root, let b denote a real number and n a natural number. We define b raised to 1 over n as b raised to 1 over n is equal to the nth root of b. If n is even, we require that b should be positive or b should be greater than or equal to 0. And number 2, let m over n be a rational number reduced to lowest terms. Assume that n is positive and that the nth root of b exists. Then b raised to m over n is equal to the nth root of b raised to m, or we can also say that b raised to m over n is equal to the nth root of b raised to m. For example, we are going to solve 4 to the 1/2. So that is the square root of 4, and the answer is 2. The next is this negative 8 raised to 1/3. So that is the cube root of negative 8. That's negative 2 times negative 2 times negative 2 is equal to negative 8. So the cube root of negative 8 is equal to negative 2. 8 to the 2/3 is equal to the cube root of 8 squared. That is equal to the cube root of 64. So that's 4 times 4 equals 16 times 4 equals 64. So the answer here is 4. Or we can also treat it as this. 8 to the 2/3 is equal to the cube root of 8 and then raised to square. So the cube root of 8 equals 2 square is equal to 4. The answer is the same. Let's solve these problems. 49 raised to 1/2, that is equal to the square root of 49, and that's 7 times 7 equals 49. So the square root of 49 equals 7. Next is negative. Then you are going to get the square root of 49. So that is negative 7. And then the third is, it says here that you have to put the negative sign first, negative 49, and then you get the square root. Now we cannot get any number because 7 times 7 equals 49. And negative 7 times negative 7 is also equal to 49. That is, it does not represent a real number because there is no real number x such that x squared is equal to negative 49. The last is 49 raised to negative 1/2. Always remember that the denominator becomes the index and that we have here the base, that's the radicand, 49, and then you get this value, negative 1. Remember that when the power is negative, it becomes 1 over. So this is not necessary. So you just have to put square root and then 1 over 49. And you can also get the square root of 1 divided by the square root of 49. The square root of 1 is equal to 1, and the square root of 49 is equal to 7. So the answer is 1 over 7.